Good morning, everybody. Today starts our new content. We are on Titan Learning Days 23 and 24, and we are starting Trig Identities. So we have gone through how to graph all of our Trig functions. We've talked about reciprocals. We've dealt with sine, cosine, tangent, cosecant, secant, cotangent, and now we're going to go a little bit further and talk about trig identities. So a trig identity is one variable is the trig equation that's true for all values of the variable for which all expressions in the equation are defined. So basically we have the reciprocal identities that we already had talked about, and that is cosecant is 1 over sine, secant is 1 over cosine, tangent is 1 over cotangent, which means just plain sine is 1 over cosecant, cosine is 1 over secant, and cotangent is 1 over tangent. We have a tangent identity, which we've already talked about, that tangent was sine over cosine. Therefore, if cotangent is 1 over tangent, that would make cotangent just the flip, which is cosine over sine. Now we're going to talk a little bit about the domain of validity of an identity. And this is going to be the set of values of the variable for which all expressions in the equation are defined. So if there is an area that it is not defined, so an undefined area, then the domain of validity will not include that. So how can an expression be undefined? Well, an expression can be, it can contain a denominator that's 0, and you can't divide by 0. So that would make it undefined, or it could contain an expression that is itself undefined for some values. So if sine was 0, that would make it undefined. Or if it was the sine of something, and that something made this go to 0, then it would be undefined also. That's all this part is saying. All right, let's move on. How do we find the domain of validity? What is the domain of validity of each trig identity? Okay, so let's just talk about a couple, and then you guys should be able to figure out the rest of them. Let's talk about cosine. So cosine is 1 over secant. So the domain of cosine is all real numbers. So think about our graph, right? It goes through the 1, and then it has our wave. And the domain of cosine theta is all real numbers. The domain of 1 over secant theta includes all zeros of secant theta, and there aren't any, and all values theta for which secant theta is undefined. And we've already stated that this is odd multiples of pi over 2. Therefore, the domain of validity of cosine, which is 1 over secant, is the set of all real numbers except for the odd multiples of pi over 2. Because at the odd multiples of pi over 2, we know that secant does not exist there, and that would be division by 0. All right, let's go with secant theta. Let's find the domain of validity for secant. So secant is 1 over cosine. So the domain of validity is going to be the same for the same reasons above here. Because secant theta is not defined for odd multiples of pi over 2, and the odd multiples of pi over 2 are the zeros of cosine theta, so it's going to have the same domain of validity. All right, something else that you might be asked to do is to verify an identity using basic identities. So if you verify the identity, what's going to be the domain of validity? So this is going to be a two-parter. We're going to have to verify it, which means we're going to have to make it equal to what it's supposed to be equal to, and then we're going to have to find the domain of validity. So the original problem is sine theta times secant theta equals tangent theta. So what I'm going to do is I'm going to change secant to 1 over cosine. So now sine times 1 over cosine is sine over cosine, which is tangent. So there we go. We verified the identity. But now we have to talk about domain of validity. So the domain of sine theta is all real numbers. So think about your sine wave, and you know domain is x, and it's continuous. So it's going to be 0 max, 0 min, 0, and it's going to keep going. So it's all real numbers. The domains of secant theta and tangent theta exclude all zeros of cosine theta. And the zeros of cosine theta are the odd multiples of pi over 2. So the domain of validity is the set of real numbers except for what's going to make cosine 0, which is the odd multiples of pi over 2. Oh, sorry about that. There you go. Now you can see it. All right, again, you can watch the video over and over again. You can send me questions on my mind. If you guys feel better meeting and going over it live, that's another possibility because we've tried to do that a couple times and it seems to work pretty well. All right, next example. I'm saying 1 over cotangent equals tangent. So that would mean 1 over cotangent equals 1 over 1 over tangent. So tangent theta is what you're going to be left with because you're going to have 1 divided by 1 over tangent, which is 1 times tangent, which is just going to be tangent. So the domain of cotangent excludes multiples of pi. Also, cotangent of theta equals 0 at the odd multiples of pi over 2. So the domain of validity is the set of real numbers except all multiples of pi over 2. All right, let's look at our next identities, which are our Pythagorean identities. So in these, we have cosine squared theta plus sine squared theta equals 1, 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. I would get a separate sheet of paper and write down all my identities so I can refer to those as I'm working my homework problems. All right, we're going to verify an identity again. So let's verify the identity that tangent squared theta minus sine squared theta equals tangent squared theta sine squared theta. All right, so let's go in and fill. We've got tangent squared theta minus sine squared theta. Tangent is sine over cosine, so we can substitute for tangent squared theta, sine squared theta, cosine squared theta, and leave the minus sine squared theta. Now bring this down. Let's get a common denominator going on here. So in order to get cosine on the bottom here, we have to multiply top and the bottom by cosine squared theta, which we did. Now we just rewrote the top all over the common denominator. Now we factored out sine squared theta. This is what's left. 1 minus cosine theta equals sine squared theta. So we are going to match. Sine squared theta times sine squared theta equals cosine squared theta. Sorry, we got to move to the second page. All right, it says sine squared theta over cosine squared theta times sine squared theta. I just wrote this over 1, and that gives me tangent squared theta sine squared theta, which is what I was trying to get. So let me put these together for you so you can see. All righty, last step here. And then I rewrote sine squared theta over cosine squared theta times just sine squared theta. That's where I got this. Then this becomes tangent squared theta, and this comes down to sine squared theta, and we verified what they wanted us to verify initially. All right, what if they want us to simplify an expression? Okay, what is the simplified trig expression for cosecant theta tan theta? All you're doing is you're substituting, eliminating, and trying to get the answer. So cosecant is 1 over sine, and let's leave tangent as tangent. Okay, next step, 1 over sine, let's change tangent to sine over cosine. These two will cancel because you can eliminate any common numerators and denominators. So as long as it's a matching top and bottom, it doesn't matter if it's vertical or straight up and down. That's going to leave me with 1 over cosine, which is going to be secant. So you can watch the video multiple times. If something confuses you, just ask me a question on the mind. If we need to do this live, like I said, we can. So try out the homework for today and tomorrow. See how you do. Make sure you're staying on task and getting these done when they're due, and make sure you're asking me questions. Have a good day, and I'll talk to you soon.